right. So now we have a presentation entitled Forest Health Monitoring in the 21st Century, Technology and Applications by Anthony Elledge and Chris Asaro. It is my pleasure to welcome Chris Asaro, a presenter. Chris has been with the Forest Health Monitoring Coordinator with the U.S. Forest Service Forest Health Protection in Atlanta, Georgia, since 2015. Prior to that, he was a state forest health specialist for the Virginia Department of Forestry from 2005 to 2015. Chris earned his undergraduate degree in biology and ecology from Cornell University, a master's in forest entomology from the State University of New York, and a PhD in forest entomology from right here, University of Georgia. It's my pleasure to welcome Chris.
Thanks. Good morning. Yeah, so this is not my normal crowd, being an entomologist, and Anthony Elledge couldn't be here, but he is attending virtually, so I'll be giving the entire talk. But he is our GIS analyst and one with the real know-how here. So if you're not familiar with the Forest Service, we have three main branches. We've got the National Forest System, we've got research, and then we've got state and private forestry. And under state and private forestry, we have this little group called Forest Health Protection, which is where most of the pretty much all the entomologists and pathologists with the Forest Service reside. So that's where we work. And you know, I appreciate Elizabeth's presentation, providing some context for a lot of these tools that I'm going to be talking about and how we're using them in sort of real world situations. But without Anthony and his skill set, GIS analyst doesn't really do justice to his skill set, but without him, we'd be really dead in the water in trying to use a lot of these tools and incorporate them in what we do every day. So again, we cover the southern region. So just for illustration here, that's 13 states from Virginia all the way to Texas, just so you know the area of coverage for our program. Before I go into details about forest health monitoring, I do want to distinguish what we do from the Forest Inventory and Analysis Program, which is probably a lot more familiar to most of you. There are important differences between the two programs. Of course, FIA is a standardized systematic sample-based plot system, and it's well designed for doing regional and national analyses of forest composition, conditions, and trends. And from a forest health standpoint, you can get a lot of information from FIA. You can look at diebacks and long-term mortality, declines, distribution of invasive plants, and impacts to major tree species. On the other hand, forest health monitoring, what we do is much more spatially explicit. It's not sample or plot based. It's basically we are collecting spatially and temporally explicit data. You know, that usually takes the form of either points, polygons, or grid cells. And this is ideal for really documenting a lot of disturbances in real time, like defoliation, rapid mortality that you might see from a southern pine beetle outbreak, the rapid spread of non-native invasive pests like emerald ash borer, and also impacts to minor tree species, which often don't get well sampled in the FIA plot system because you only have one plot every 6,000 acres. And sometimes a lot of stuff is going on that falls in between those plots. So the main emphasis of forest health monitoring is what we call detection monitoring. It's a nationally standardized aerial, these are nationally standardized aerial and ground surveys to evaluate status and change in conditions of forest ecosystems. Now, most of this work is carried out by us in FHP, but also our state partners in the state forestry agencies, particularly in the eastern US, where most of the land is private rather than federal. So we rely very heavily on the state forestry agencies, almost all of whom employ a forest health specialist. And that was sort of my background too. I used to do that work for Virginia. Now I'm on the federal side. And of course, we're increasingly using the tools of remote sensing. One application developed by Forest Service Research is called Forewarn. It's a change detection platform that has been based on MODIS, but since MODIS is gradually going away, it's transitioning to Sentinel-3. We also make heavy use of Worldview, NAPE, and other 1 meter sort of resolution imagery. But the gold standard approach remains manned aerial survey. And this may surprise some of you. Do we actually still do this? We actually put people in little cockpits that are often very hot, and you're bouncing around up there and you're trying to map these disturbances. We use tablets now. When I started, we were still using paper topo maps from USGS and a pencil. But yes, we still do this. And most of the data that we collect is still collected this way. And the reason is very simple. It's still the most cost-effective and efficient way to collect this type of data at this scale, which is all 50 states. We do this. So that's why we still do it. We do have a more standardized approach using what we call digital mobile sketch mapping, or DMSM, making use of tablets, usually Samsung tablets, and proprietary software that the Forest Service developed specifically for this purpose. And we have very specific surveyor protocols, and usually the people doing the surveys are very experienced people. They're often folks with master's degrees in entomology, forest entomology or pathology, and they have a lot of experience knowing what disturbance agents are common in their area. We also do a lot of ground survey. Ground survey, whether you're doing manned aerial survey, whether you satellite imagery, ground survey is essential to the quality of our data. Having experts on the ground that can verify what you're putting on a map, saying, yes, this is the cause, or this is what's going on here. That's really a critical component of our survey work, is to be what we call ground truth. Again, whether it's aerial survey or remote sensing. And as you heard about some of these tech tools earlier, we're using Collector, starting to use Field Map, Survey 123, and DMSM on the ground as well for a lot of different surveys. So the types of things that we map, as I already mentioned, things like emerald ash borer mortality, defoliation from forest tent caterpillar, which is a native insect, and a lot of invasive species like gypsy moth, which is slowly inching its way further south, and eventually will start causing this kind of damage in Tennessee and North Carolina, to name a few. So this is what the digital mobile sketch mapping software looks like when you're mapping on a tablet and you're in that cockpit. It's a little bit antiquated. It was developed about 10 years ago. But it's really good software, and with upgrades, it really does the job well for us. Now, in the past, when you used to do aerial surveys with paper maps and pencil, the hardest part about learning to do that and doing it efficiently was figuring out where you were relative to the landscape. You had to look at your GPS unit about every minute, and then try to interpolate on your map degrees, minutes, seconds, and say, okay, this is where I am. Now I can draw what I see outside the plane. It was a very difficult thing to learn and to get good at. Well, this tool takes that whole effort out of the mix, because with the Bluetooth attached to the tablet, you know where you are at all times with that plane icon. So you don't have to think about that nearly as much, and you can focus on drawing a polygon. And you see those panels to the right there. Those are called quick keys. Another feature that's nice is if you see a lot of common things every year, the same things every year, and you kind of know what to expect when you go up there, you can develop these. You can pre-program these quick keys like southern pine beetle, gypsy moth, whatever it is, and with one click of the button, you can attribute that polygon to that damage-causing agent. So that's another nice feature. So it's gotten a lot more efficient. to do these kinds of surveys. And it's actually gotten a lot easier to train people because we have a lot of turnover in these types of positions. And very often you have a pretty steep learning curve. So this has really helped. Technology has really helped people get skillful at this fairly quickly, assuming you have the stomach to do this kind of work. Not everybody does, but. And you heard about ArcGIS Online. One thing I really like, I don't do the surveys anymore myself, but I receive all this data through this map viewer, which is just absolutely fantastic. I mean, it makes my job so much easier since I'm kind of corralling all this information because I can keep track of what's going on in real time. I can see the flight lines. I can see the types of damage that are happening, and it just really facilitates communication and coordination with all of your partners. So just zooming in on Mississippi, this was those pink lines are the flight lines, and all the red dots are southern pine beetle of different to different degrees depending on the size of the dot. And you can click on any of those and get additional attributes: who did the flight, the date of the flight, the damage causing agent, the intensity of the damage, number of trees. All that information is in there with the click of a button. So it's really a nice development that we've that's helped me do my job. Now, I mentioned that there are limitations to satellite imagery. We know this is the future, and we know this is how things are going to be done going forward. But for a lot of reasons, we can't just stop doing aerial surveys cold turkey. That's going to be an important tool in our toolbox for years to come. But we are starting to incorporate satellite imagery into our day-to-day operations and to complement the aerial survey. A lot of the difficulties with satellite imagery are, obtaining coverage that's really widespread for specific footprints. You got a mountain pine beetle outbreak that spans 8 states in the Western US. Good luck getting all the imagery that you need to try to map that. That could be, that information could be collected in a matter of weeks with some skilled aerial surveyors going out there. Cloud cover is a problem. You want worldview imagery of something that's happening, right now. Good luck getting cloud-free imagery in the summertime or in the mountains. It's very, very difficult. Ground verification. You can get satellite imagery for remote areas, which is really nice. But, trying to get out there on the ground to figure out what it is that's causing the disturbance is always going to be a challenge. We don't yet have good reporting standards like we do with aerial survey because we've been doing aerial survey for so long. And you need terabytes of storage required for these large areas. Getting 1 meter imagery for an entire state is a big storage problem. It's becoming less of an issue every year, but it's still an issue. And then of course you got processing and upload download times, imagery costs, $25 or more per square kilometer, licensing issues, and training. I mean, we have a lot of really smart people in the Forest Service that know how to handle this imagery, but they're not spread out throughout the agency in a way that we can really exploit imagery at the scale that we will need to in the future. So we really have some workforce limitations there as well. Now, you can take a satellite image like this 1 meter, this is worldview, and if you're lucky enough to get a cloud-free image, there's no reason why you couldn't download this onto your DMSM tablet and draw a polygon around it and call that southern. This is a southern pine beetle spot on or area on one of our national forests. That's a perfectly valid approach. We call that pan and sketch. You can just from your office, you can pull down an image and just put a polygon around it, sync it to the cloud, and we've got the data. No different than if you flew over it in a plane and drew a polygon. But again, the reason that we don't do this all the time and everywhere is all the reasons I mentioned before about acquiring satellite imagery. Try doing this for a whole state. It's not so simple. So yeah, the technology is there, but we still have a long way to go before this is our sort of bread and butter tool. There we go. Okay, so when we summarize all this information, this is kind of what it looks like in a typical year. This is 2019. All the red is just the cumulative damage that we map. You can see there's quite a lot of it. And these could be points, polygons, or grid cells. It's hard to tell at this scale. You can also see the areas that we surveyed with aerial survey in gray. We take all those flight lines that are synced to the tablet and we buffer them, which means we put about 2.5 miles on each side of the line, because that's about how far you can see when you're flying at about 2,000 feet on either side of the plane. So that's kind of a standard buffer that we use. And it allows us to come up with an acreage for how much aerial survey coverage we have every year. So we keep track of that. But I should point out, all the white areas where there's no coverage, that doesn't mean that there might have been something big going on that we missed because we didn't fly it. There is a lot of ground truth that goes on, pretty extensive road network in the east, a lot of people on the ground. So some states kind of fly on an as needed basis and rely on their ground truth and satellite imagery increasingly to kind of cue them in on, is there something going on or not? Do we need to fly this area or not? So you'll just see a lot of variation there in coverage. And we tabulate the data. We present it in a lot of different ways. We break it out by defoliation, mortality, and other types of damage. This breaks it out 4 different ways. We've got also uprooting and branch breakage for storms, crown discoloration. This is actually from 2020. You notice very little aerial survey coverage that year. That was because of COVID. A lot of states were prevented from flying very much that year, but we still mapped quite a lot. Notice Louisiana, that big blob of blue there. That's actually the impact from Hurricane Laura. This is the first year that we used DMSM and an aerial surveyor to map a hurricane. And we used to not do it because it was just impractical. When we were only dealing with polygons, you know, that type of disturbance where trees are just on the ground every which way and, you know, snapped in half, it was a very difficult signature to draw. You know, where do you start your polygon? Where do you finish it? It was just not anything that was very practical. But with grid cells, where you can assign a damage, you know, a percentage of forest cover that's damaged to a certain degree within a grid cell, that's doable. You're dealing with a range. So let's see. Yeah, so this is a stylized version of that on the left there. It shows you the grid cells. It shows you the damage level. You know, when you're flying at 150 miles an hour, you can only be so accurate. Your eye can only distinguish, you know, you can't distinguish 20 from 25% damage, but you can distinguish 10% from 30%, from 50%. So we have these ranges within each grid cell that the surveyor selects, and you can see the different colors that break that out. Now, if you compare that with an NDVI change detection image on the right, you see that the pattern, the footprint, very similar. That red area on the right is the highest NDVI change for that area. So, and the reason the aerial survey is more useful in this context is we can pull damage estimates out of that. And I won't go into the details of how we do that, but because each of those grid cells has described a damage level, we can come up with acres. And that's really important for things like a supplemental funding request to Congress, which a lot of states will do after a major disaster. They need to produce some type of acre estimate for how much they're requesting funds to assist landowners in recovering. So there's a lot of use for this kind of data. We're also doing a lot of new things that we didn't do in the past, kind of looking at indicators of climate change and abiotic disturbances. One example is ghost forests, coastal ghost forests, which some of our state agencies are starting to map. Ghost forests basically are areas of standing dead trees that no longer support forest growth because of sea level rise and salinization, where you're getting forest land being converted to marsh habitat. It's too salty for trees to grow. And we're seeing that all up and down the Atlantic coast due to sea level rise and the Gulf Coast. So having data on, you know, how many acres have been lost to ghost forests is very valuable, and having a baseline so that we can compare it with future estimates. So these are other applications for that we're starting to get into with digital mobile sketch map. And Anthony's put together a lot of cool ways to present this data now that we're actually a little behind a lot of our state partners. You know, the federal government is like a big ship, you know, kind of lumbers forward, and it takes a lot of effort to steer it in a different direction. But we're starting to catch up with what folks in industry are doing, and so we've got this Esri dashboard now that we're using to summarize this data, and we're going to start working backwards towards, you know, earlier years, because we have spatial data going back probably about 20 years. So you can query this dashboard by year, state, damage agent, damage type, custom formatting using arcade scripting. And as I mentioned, we're developing this for our past data as well as data that we're currently collecting. Story maps are really popular now. So that's another thing that we're doing for developing for current and prior year summaries and notable events like hurricanes. Very valuable tool to communicate what's going on, easy to read, and you don't have to be, you know, easy for laymen to kind of look up and get it. And it's very easy to update too. So these are really nice, convenient ways to present this information. We have a southern pine beetle management system. Southern pine beetle is still one of our key pests in the South because of the importance of the pine timber resource. And ArcGIS collector is used for data collection as part of a larger system that consists of all various inputs, data integration, and outputs used to collect and report forest damage in the southern region. And this is all integrated with AGOL. And I won't go into the details of that flow chart, but just gives you an idea of how we're using all these tools kind of collectively. And we do a lot of analysis and reporting at the Forest Service level. A lot of states write their own reports that go on our FHM webpage, their forest health highlights. We also do regional reports, and more specifically, we have a national technical report every year that comes out. It's a big, thick book. We're trying to get it more streamlined so people can access it more easily, but you can download these. And this is where we kind of put everything together. We look at FIA data, we look at the FHM data, we look at NOAA data, and there's chapters and analyses written about, you know, drought impacts and climate change and all kinds of things. So that's a good report to check out. And to summarize, we collect forest disturbance data from insects, diseases, abiotic disturbances that's spatially and temporally explicit, and is collected by people with expertise in these fields of entomology and pathology. So that's what makes this data high quality and unique from other data sets. The methods and tools include aerial survey with tablets and specialized software, ground survey by specialists, and satellite imagery, and increasingly drones. People always ask us about drones. Are you using drones? Yes, we're definitely using drones, our state partners. But remember, the scale that we collect this data and the precision that you get from a drone, they don't quite match up. Drones are really great tools for stand level type analyses, but for most of our applications, we don't need to see individual leaves on trees. And you get that level of precision with drones now. But someday, when you know, we can send up a fixed wing drone to cover a whole state at a reasonable cost, well, that's what we'll do, right? That's the future, but we're not there yet. And we store this data as points, polygons, or grid cells from which acres of damage can be derived. And the most important point is, I think, the quantity, the quality, and the variety of all of this disturbance data captured will continue to expand exponentially and improve with these new technology capabilities and with newly emerging threats. So we're going to be swimming in data, and we're not going to be able to process it all ourselves and analyze it all ourselves, but we'll continue to collect it, and we hope, and it's freely available. You can download all this data from our websites. They're easy to find, and we hope, you know, the research community makes use of it. Thank you.